microcontroller. 8352 8-bit control-oriented microcontroller. 8354 8-bit control-oriented microcontroller. 8358 8-bit control-oriented microcontroller. 8751 8-bit control-oriented microcontroller. 8752 8-bit control-oriented microcontroller. 8754 8-bit control-oriented microcontroller. 8758 8-bit control-oriented microcontroller. Intel 80151. Single accumulator Harvard architecture. MCS 151 Family 80151 High Performance 8-bit Control-Oriented Microcontroller. 83151 High Performance 8-bit Control-Oriented Microcontroller. 87151 High Performance 8-bit Control-Oriented Microcontroller. 80152 High Performance 8-bit Control-Oriented Microcontroller. 83152 High Performance 8-bit Control-Oriented Microcontroller. Intel 80251. Single Accumulator Harvard Architecture. MCS 251 Family 802518/16/32-bit microcontroller. 80252 8/16/32-bit microcontroller. 80452 8/16/32-bit microcontroller. 83251 8/16/32-bit microcontroller. 87251 8/16/32-bit microcontroller. 87253 8/16/32-bit microcontroller. MCS 96 family. 8061 16-bit microcontroller. Parent of MCS 96 family ROMless with a /D, most sold to Ford. 8094 16-bit microcontroller, 48-pin ROM-less without a /D. 8095 16-bit microcontroller, 48-pin ROM-less with a /D. 8096 16-bit microcontroller, 68-pin ROM-less without a /D. 8097 16-bit microcontroller, 68-pin ROM-less with a /D. 8394 16-bit microcontroller, 48-pin with ROM without a /D. 8395 16-bit microcontroller, 48-pin with ROM with a /D. 8396 16-bit microcontroller, 68-pin with ROM without a /D. 8397 16-bit microcontroller, 68-pin with ROM with a /D. 8794 16-bit microcontroller, 48-pin with a ROM without a /D. 8795 16-bit microcontroller, 48-pin with a ROM with a /D. 8796 16-bit microcontroller, 68-pin with a ROM without a /D. 8797 16-bit microcontroller, 68-pin with a ROM with a /D. 8098 16-bit microcontroller. 8398 16-bit microcontroller. 8798 16-bit microcontroller. 80196 16-bit microcontroller. 83,196 16-bit microcontroller. 87,196 16-bit microcontroller. 80,296 16-bit microcontroller. The bit slice processor. 3000 family. Intel D3002 introduced in the third quarter of 1974. These bit slicing components used bipolar Schottky transistors. Each component implemented 2 bits of a processor function. Packages could be interconnected to build a processor with any desired word length. Members of the family: 3001 microcontrol unit. 3002 2-bit arithmetic logic unit slice. 3003 look-ahead carry generator. 3205 high-performance 1 of 8 binary decoder. 3207 quad bipolar TMOS level shifter and driver. 3208 hex sense amp and latch for MOS memories. 3210 TTL TMOS level shifter and high voltage clock driver. 3211 ECL TMOS level shifter and high voltage clock driver. 3212 multimode latch buffer. 3214 interrupt control unit. 3216 parallel, inverting bidirectional bus driver. 3222 refresh controller for 4K, 4096B, MOS DIMs. 3226 parallel, inverting bidirectional bus driver. 3232 address multiplexer and refresh counter for 4K DIMs. 3242 address multiplexer and refresh counter for 16K, 1024B, DIMs. 3245 quad bipolar TTL TMOS level shifter and driver for 4K. 3246 quad bipolar ECL TMOS level shifter and driver for 4K. 3404 high performance 6-bit latch. 3408 hex sense amp and latch for MOS memories. 3505 next generation processor. Bus width 2n bits data forward/address. Depending on number n of slices used. The 16-bit processors, MCS86 family. Intel D80868086. Introduced the 8th of June, 1978. Clock rates 5 MHz, 0.33 MIPS, 4. 8 MHz, 0.66 MIPS. 10 MHz, 0.75 MIPS. The memory is divided into odd and even banks. It accesses both banks concurrently to read 16 bits of data in one clock cycle. Data bus width, 16 bits, address bus, 20 bits. 29,000 transistors at 3 micrometers. Addressable memory 1 megabyte, 10,242B. Up to 10 the performance of 8080. First used in the Compaq Desk Pro IBM PC compatible computers. Later used in portable computing, and in the IBM PS/2 Model 25 and Model 30. Also used in the AT&T PC 6300/Olivetti M24, a popular IBM PC compatible, predating the IBM PS/2 line. Used segment registers to access more than 64 kilobytes of data at once, which many programmers complained made their work excessively difficult. The first x86 CPU. Later renamed the IAP x86, 7. Intel D80888088. Introduced the 1st of June, 1979. Clock rates 4.77 MHz, 0.33 MIPS. 8 MHz, 0.66 MIPS, 4. 16-bit internal architecture. External data bus width, 8 bits, address bus, 20 bits. 29,000 transistors at 3 micrometers. Addressable memory 1 megabyte. Identical to 8086 except for its 8-bit external bus, hence an 8 instead of a 6 at the end. Identical execution unit, EU. Different bus interface unit, BIU, 7. Used in IBM PC and PCXT and compatibles. Later renamed the IAP x88, 7. Intel C801866 MHz 80186. Introduced 1982. Clock rates 6 MHz, and GT1 MIPS. 55,000 transistors. Included 2 timers, a DMA controller, and an interrupt controller on the chip in addition to the processor. These were at fixed addresses which differed from the IBM PC, although it was used by several P-compatible vendors such as Australian company Cleveland. Added a few opcodes and exceptions to the 8086 design, otherwise identical instruction set to 8086 and 8088 bound, enter, leave. INS, outs. IML push pusher, papa. RCL /RCR /ROL /ROR /SHL /SHR SAL /SAREG, in. Address calculation and shift operations are faster than 8086. Used mostly in embedded applications, controllers, point-of-sale systems, terminals, and the like. Used in several non-PC compatible DOS computers including RM Nimbus, Tandy 2000, and CP/M86 Televideo PM16 server. Later renamed to IAP X186. 80188. A version of the 80186 with an 8-bit external data bus. Later renamed the IAP X188. Intel C802866 MHz 80286. Introduced the 2nd of February, 1982. Clock rate 6 MHz, 0.9 MIPS. 8 MHz, 10 MHz, 1.5 MIPS. 12.5 MHz, 2.66 MIPS. 16 MHz, 20 MHz and 25 MHz available. Data bus width, 16 bits, address bus, 24 bits. Included memory protection hardware to support multitasking operating systems with per-process address space. 134,000 transistors at 1.5 micrometer. Addressable memory 16 megabytes. Added protected mode features to 8086 with essentially the same instruction set. 3/6 the performance of the 8086. Widely used in IBM PC and at clones contemporary to it. 32-bit processors, the non-x86 microprocessors. IAP X432. Introduced the 1st of January, 1981 as Intel's first 32-bit microprocessor. Multi-chip CPU. Object/capability architecture. Microcoded operating system primitives. 1 TB virtual address space. Hardware support for fault tolerance. 2-chip general data processor, GDP, consists of 43,201 and 43,202. 43,203 interface processor, IP, interfaces to E/O subsystem. 43,204 bus interface unit, BIU, simplifies building multiprocessor systems. 43,205 Memory Control Unit, MCU. Architecture and Execution Unit Internal Database Paths, 32 bits. Clock rates 5 MHz. 7 MHz. 8 MHz. I-960 aka 80960. Introduced the 5th of April, 1988. RISC-like 32-bit architecture. Predominantly used in embedded systems. Evolved from the capability processor developed for the BIEN joint venture with Siemens. Many variants identified by two-letter suffixes. I-860 aka 80860. Introduced the 26th of February, 1989. RISC 32/64-bit architecture, with floating point pipeline characteristics very visible to programmer. Used in the Intel IPSC/860 Hypercube parallel supercomputer. Midlife kicker in the i870 processor, primarily a speed bump, some refinement /extension of instruction set. Used in the Intel Delta massively parallel supercomputer prototype, placed at California Institute of Technology. Used in the Intel Paragon massively parallel supercomputer, placed at Sandia National Laboratory. X-Scale. Introduced the 23rd of August, 2000. 32-bit RISC microprocessor based on the ARM architecture. Many variants, such as the PXA2XX applications processors, IOP3XXI/O processors and IXP2XXX and IXP4XX network processors. 32-bit processors, the 80386 range. Intel 80386DX Intel 80386DX with Intel 387 Math Processor 80386DX. Introduced the 17th of October, 1985. Clock rates 16 MHz, 5 MIPS. 20 MHz, 6 to 7 MIPS. Introduced the 16th of February, 1987. 25 MHz, 7.5 MIPS, introduced the 4th of April, 1988. 33 MHz, 9.9 MIPS, 9.4 SPE SINT 92 on compact /I16 kilobytes L2, introduced the 10th of April, 1989. Data bus width, 32 bits, address bus, 32 bits. 275,000 transistors at 1 micrometer. Addressable memory 4 GB, 410,243B. Virtual memory 64 TB, 64 10,244B, 8, 9. First x86 chip to handle 32-bit data sets. Reworked and expanded memory protection support including paged virtual memory and virtual 86 mode features required at the time by Xenix and Unix. This memory capability spurred the development and availability of OS/2 and is a fundamental requirement for modern operating systems like Linux, Windows and Mac OS. First used by Compaq in the Desk Pro 386. Used in desktop computing. Unlike the DX naming convention of the 486 chips, it had no math coprocessor. Later renamed Intel 386DX. 80386SX. Introduced the 16th of June, 1988. Clock rates 16 MHz, 2.5 MIPS. 20 MHz, 3.1 MIPS, introduced the 25th of January, 1989. 25 MHz, 3.9 MIPS, introduced the 25th of January, 1989. 33 MHz, 5.1 MIPS, introduced the 26th of October, 1992. 32-bit internal architecture.